So since we're gonna be looking at transverse waves, um, do you remember the formulas I showed you on Thursday?
Mhm. Yeah, I remember it was that energy thing. Was that E equals, I don't know, F,
HF.
HF.
It's Planck's constant and frequency.
Mm.
So that H is basically Planck's constant. So the formulas I showed you on Thursday was E equal to HF,
Mm.
which is also equal to H speed of light over the wavelength.
But you see, the thing about this topic is, I don't know if we're still gonna do this part because we didn't learn any formulas yet. Like it's still in the basic.
But
So,
I don't think
mm,
I don't think we're gonna need it for question 6. But I'm
mm,
just taking it like a step further so that you know what to expect, because question 6 you're not gonna need it, but question 7 it's also based on waves, and there
mm,
they want you to calculate
yeah,
like the wavelength and the speed and stuff.
okay.
But anyway, I think we should just do this question 6, open another question paper, try to find another question on the same level as this one, because
Yeah,
you guys haven't done the formulas yet, and
yeah, yeah.
so let's just go here. Question 6. Two girls are standing at opposite ends of a rope, each making a pulse of the same speed. Pulse A has an amplitude of 4 centimeters. So you know that pulse A is positive, and pulse B
Yeah,
has an amplitude of negative 6 centimeters. So B is negative, and A is moving to the right, whereas B is moving to the left,
left.
and they're gonna meet at point C.
Mm,
So just from this information that we've gathered, you should be able to derive some some information about the way about the pulses that are gonna meet. So
So we
from
know that this is it's a, what do you call it? A destructive.
that's gonna be destructive interference.
Mm,
And then once you already looked at like the directions of of the waves, same time you say it's destructive interference, you already know the directions of the wave because A is positive and B is negative.
yeah,
Then you have to look at the magnitudes too, so you can find out what the resultant pulse is gonna be.
yeah,
Just looking at the magnitude, -6 and +4. This is greater than +4, so you know that the resultant pulse is gonna be something down on this side,
yeah,
and it's gonna travel to the left.
yeah.
But anyway, let's start. So 6.1, they say state what phenomenon is observed. State the phenomenon observed when the two pulses meet at point C. So since they just want you to state it, you already said it, it's gonna be destructive interference.
Mm,
Yeah, at the superposition of C. So Now they want you to draw a label diagram to show the resultant pulse when the pulses meet C. So it's gonna be something like this. Sorry, let me just rub this out. It's gonna be something like
So they don't want you to draw the whole thing. They just want to show you, like they just want
they just
us
want
to draw.
the resultant
Okay.
pulse.
But it would be wrong if I had to draw the full diagram, including that.
I don't think it would be wrong. I think they would recommend it, to be honest, because they say label the pulses clearly. So if you can, you probably should. So this is going to be negative with an amplitude of -2 centimeters.
It's just saying 4 - 6.
Yeah,
Yeah.
it's not actually 4 - 6. It's actually the total, right? The
Mm.
total, total. It's actually gonna be. It's actually gonna be A.
Minus B.
Nah, it's gonna be plus B.
Plus
Because
B.
remember, now we're gonna be working with integers. So
Mm-hmm.
this is gonna be +4 in brackets, and
Oh,
it's gonna
plus
be
minus C.
plus into -6.
Oh, okay, I see.
Yeah, so total, which is C, you're gonna get -2 centimeters. So the actual equation is this one. It's just that when you substitute, one is gonna be positive and the other is gonna be negative.
Yeah.
Yeah. So this is the resultant pulse at C. So they say name the type of interference that takes place when the pulses meet. That's
But before we
destructive
go on,
interference.
by question 6.1, where they say state the
The
phenomena observed
phenomenon,
during
yeah. That's why, like, if 6.3,
the
they
oh,
say name the type of interference.
mm. So
That's
that's where you say the
probably that probably means that in 6.1, it's not gonna be destructive interference. That's not the
mm.
phenomenon. Um, Actually, I think when they say state, nah, because
Yeah.
this is a 3 mark question.
Yeah, that's what I was wondering.
Yeah, so it's probably gonna be 1 mark for stating the phenomenon and 2 marks for defining it.
Oh, okay.
Uh, I think here it's gonna be the principle of superposition or just superposition.
Okay.
So the principle of superposition is that when two pulses meet, there's gonna be an interference at a certain point.
Okay. Yeah,
So I
where
think,
superposition occurs when two waves meet or overlap. The
yeah, or
resulting wave is the
overlap.
sum. The resulting wave is the sum of the amplitudes of the two
Exactly.
individual waves.
That's why here this is the amplitude of A and this is the amplitude of B. So the resultant is gonna be the sum of amplitudes. I think that's the one they want. Now you know what? It has to be the one they want because mostly in physics and chemistry,
Mm.
the statement you define above, you're mostly gonna use it in the next question.
Yeah.
So if you look at it, you said when two waves overlap, they're gonna overlap, and the resultant pulse is gonna be the sum of the amplitudes. And that's the equation that we used here.
Yeah.
That's the equation from here.
The total, yeah.
Yeah, so it's most likely gonna be the principle of superposition. So they say determine the resultant amplitude at point C. We already did that. It's here. Then they say how will the amplitude of pulse A be affected after passing point C? So you're gonna write down it's gonna increase, it's gonna decrease, or it's gonna remain the same. So from this information, you can see that pulse A, the amplitude of pulse A is gonna decrease.
Yeah.
So I think that's an easy 9 marks. Let me just try to open another question paper here. Uh, yeah. Let me erase all these things. Now, why is this the memo now? Do I just have two memorandums? How? Uh, let me just go on the website then real quick. So do you know which website to use for past question papers?
No.
I'll probably send it to you. I'll probably send you the link. So you can see that this is the website that I use for past question papers. Let me just zoom in fully.
This is where you get your past papers.
Yeah.
Mhm. Yeah, just send it to me, please, when you're done.
Yeah. Plus it has the memos and everything. So 2017. Let's just do 2016.
For all subjects.
All subjects that are offered in South Africa.
Yeah. Okay.
Let's fast forward to question 6. Yeah, this one is gonna require the equations. Because remember from what I told you, usually you guys have to use the equations.
Yeah.
Yeah, they're not gonna offer you like easy questions like the ones they give you in your classwork and stuff.
But the previous question 6, is that gonna be included also?
That's also possible, but it's less likely.
This is
Like
like
if they give you,
the main part to calculate the length wave and all that.
Yeah.
and using
Basically, let me just help you through this question six, right?
mm,
Because I'm pretty sure like after light, you're gonna be doing after waves, you're gonna be doing sound.
mm,
Oh, let me just place this somewhere nicely. So they say the diagram below is a graphic presentation of a transverse wave moving from the left to the right across the page. So they give you the speed. It moves at zero point 0.4 meters per second.
mm,
And they give you the frequency, which is 0.5 hertz.
mm,
And these are just points on the wave, A, B, C, D,
yeah,
and E. So from looking at this,
yeah,
you can be able to find the period, the time it takes for one full wave to be completed.
mm,
You look at you can look at this. Let me just choose a different color. Look at this wave. It's gonna start here, then it's gonna end here.
yeah,
So the time it takes for this wave to occur, it's 2 seconds. And this one is gonna start here, ending here, 2 seconds.
mm,
So just from the graph itself, you can find the period.
yeah. And period is T.
Yeah, period is capital letter T.
Okay.
Then they say write down the amplitude of the wave in meters. So the amplitude is the highest point on the wave. So here it's 40 centimeters.
Mm,
So to convert from centimeters to meters, you just divide it by 100. So 40 divided by 100 meters, which is gonna give you 0.4 meters.
yeah.
So that's your amplitude for this wave.
Oh, okay.
That's your amplitude for the wave.
So you just take the highest point and change it into what if it was already in meters? Like, what do they always give it to you in centimeters? Or
Not really. Usually the values differ. They can give it to you in centimeters, they can give it to you in decimeters, in meters, kilometers, whatever they feel like. As long as you know how to convert from
yeah, but okay,
meters to kilometers and all that stuff, it's gonna be easier.
okay, but then like in this graph, we're working with centimeters, right?
Yeah,
So when they say write down the amplitude of the wave, then they will tell you like what unit you must change it to.
yeah, they will tell you what
Okay,
what unit you must change it
okay,
to.
okay. I thought it's just that it's always gonna be one, like
Um,
one.
when it comes to science, right? That's why we have our SI units.
Mm,
So usually when you're gonna substitute into an equation, you need to use your SI units
mm,
because now if they say give the amplitude, you should know that distance, anything that involves distance, is gonna be in meters, and
okay.
anything that's gonna involve like velocity and stuff, you have to state it in meters per second,
Yeah,
unless your teacher states otherwise. So that's
yeah.
the only situation where like you can change it if
Oh,
if your teacher says don't write it like this, write it like that.
yeah, yeah.
Yeah. Um, let me just erase all of this. It's not giving me like a time warning, so let's just continue. Um, so from here, they say label the points marked D and E. So if you look at D and you look at E,
Mm.
um, you can see your y value. It's 40 and negative 40. Yeah.
Yeah.
So for D and for
Equal to 40.
E, like usually when they say label them, I think they're gonna want the coordinates.
Oh, okay, okay.
Yeah. So for D, it's gonna be something and negative 40. And for E, it's gonna be something and 40.
So now we must just find the x values.
Yeah. So if you look at it at this point,
Is it 4,5?
yeah, it's 4.5 just from looking at the graph.
Okay.
Sorry, 4.5 because E is hot is a
In the middle.
quarter of this wave.
Mm.
Yeah. So if it takes 2 seconds to complete a wave, it takes 0.5 seconds to complete a quarter wave. So you just take 4 and add that 0.5. Then D is also gonna be 3.5.
Mm.
Yeah. Um uh, you know what? Since it's already like counting down and stuff,
Join a new one.
yeah, let's do a new one and complete question 6. Then we can do something else afterwards.
Okay.
Yeah. Let me just stop